Okay, I've decided to create video questions, so short videos which contain questions on electricity, which look at the fundamentals of what I think you need to know, and I'll also have the solutions on video as well. All of these will be available on YouTube as they get produced. It's an expectation that you do all of the problems and you attempt them first, then look at the solutions. Okay, so in our first problem, we've got an electric circuit, and here's our 12-volt battery. And the circuit has got two branches, as you can clearly see, and each of these is a globe. So all of the current coming out of the battery will pass through our 100 ohm globe, and then there'll be a branch. Some will go this way through the 100 ohm globe here, and some of the current will pass this way through both of these globes. The current will recombine and return to the battery. So the very first question is, what is the total resistance of this circuit? So, in other words, what is the total resistance of all these resistors combined for this circuit? Question 2, what I'm asking you to do here is calculate the current leaving the battery. So, based on the answer that you got for question 1, work out how much current is leaving this battery. Okay, the next lot of questions, question 3, 4 and 5. What I want you to do is to draw an arrow showing the direction of the current in this circuit. Question 4, draw an arrow showing the direction of electron flow. And finally, question 5, using a different colour, show the actual path the current follows through this circuit. So starting at the battery, show the pathway that the current follows, and if it branches into two different pathways, try to show diagrammatically what proportion of the current will go one way and what proportion will go through the other. You don't have to be absolutely spot on, and it doesn't require any calculations. So we're just looking for a visual answer. Okay, questions 6, 7 and 8. Here, I'm asking you now to work out the current flowing through individual components. Now, resistor A or globe A is over here. It's 100 ohms. So I want you to work out how much of the current is flowing through globe A or resistor A. Question 7 and question 8, I want you to work out how much of this current is going to pass through resistor B or globe B, and how much of that current is going to go this way, passing through globe or resistor C. So that's what you need to do for those questions. For question 9, you'll notice I've now drawn a whole lot of dots around the circuit, and I've labelled them different colours. And I've also indicated a couple of key points. So here's position A, position B, C, D, E, and so on. Now, using the idea that we discussed in class about the idea that as current flows around a circuit, particularly when it flows through a resistor, it loses electrical potential energy. What I want you to do is to calculate how much electrical potential energy each coulomb of charge has when it's at each of these positions. So position A, how much electrical potential energy does each coulomb have? How much does each coulomb have when it's at position B? C, D, E, and so on. And I'll give you a heads up, at position A, because the current has just come out of the battery, then each coulomb will have 12 joules of energy. And at this dot here, because it's about to return to the battery, its electrical potential will be, in fact, 0. In this final question, question 10, I want you to calculate the potential difference across each of the globes or each of the resistors. Now notice I'm saying the potential difference. And to remind you, if I wanted, for example, to measure the potential difference across globe A, I would connect a voltmeter across globe A like this. And remember, The potential difference is the difference in electrical potential energy between 2 points in a circuit. And if we're looking at the difference in potential energy per coulomb, then that will be measured in volts. Remember, 1 volt of electrical potential difference is equal to a difference of 1 joule per coulomb of charge.